the title of his presentation, that is oil reclamation in service or transformer using fuels, earth, and experience. You may proceed. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Actually, I'm Shahrin Abdul Ghani from University Technical Malaysia Melaka, and our study. Just I want to share our experience on using this full earth as one of the absorbents that they have been discussed. Like Nazlina have said, they are using the natural absorbents, but this time I'm using the common commercial available of full earth absorbents. So we are dealing with the in-service. We're doing the reclamations of the in-service power transformer oils by using the full earth and sharing the experience on using it. It is some sort of like a review, but we did some experimentation on that. So commonly, as we know, as I'm in electrical, so maybe here we are commonly see in substation, in electrical substations, we do have the transformer. Have you ever seen this transformer substation? Mainly in the subway of road, maybe there's a substation, there's a power transformer there, not a Megatron on that, but this is a power transformer. What this power transformer itself do is convert the electrical voltage from the low to the high voltage in transmission, and then it converted to distribute in the low voltage terms. So this is a very crucial, it's a very crucial component in distributing our energy system to make sure that we didn't get any lack of energy, electrical supply. So currently in TNB, in a utilities company, they are using an oil immersed power transformer. Means that in the transformer itself, we do have, it have an insulating oil inside. Means that it's covered on giving the insulation of the high voltage inside the transformer itself. Second, we become as a coolant in the transformer, and also we become an information carrier on the transformer health index inside. So what happened if we didn't have a proper maintenance on the transformer? The crucial or the drawbacks will happen to the transformer is it will be explode. What will happen if the transformer explodes? What will happen if the transformer explodes? If the power transformer explodes? So we do have the blackout. So what will happen if us having a blackout? What will happen to us? We will become angry. Do you angry if there's a blackout? Are you okay? If nothing, if electrical supply is okay? So the main okay, so the faults maybe come from the moisture. Okay, it's come from the moisture or thermal stresses and electrical stress, which deteriorates the insulating oil properties. Okay, the insulating oil properties we focus is on maybe it contains some acids, sludge, and some we call conductive particles that produced in the insulating oil. So since they are using the mineral oil, means that it having a such of threatening of aging mechanism inside the transformer oil. So the aging itself will increase the acidity number of the oils, of the insulating oils, and also increase the moisture terms inside the transformer oil. means it can increase the conductivity, the electrical conductivity of the oil itself. So the other techniques on reducing if you want to do the maintenance inside the transformer oil, so they are applying on using recycling the mineral oil. They call as a reclamation process. So this is the oil we have. Actually, it is some type of actually the transformer oil itself is like just a plain water. Okay, there's a very bright color. But after having a high aging, a thermal stress, it will change into the black color. So if you're having the black color ones, means that the transformer oil will become, the acidity inside the oil will be higher. If the acidity is higher, means that it will prone to reduce the electrical integrity of the power transformer itself. So how the reclamation process do? So we do this by applying the fuller earth inside the transformer oil, and then we do some reclamation, and then we try to see either we can improve the dielectric strength of the insulating oil, the interface tension, or the total acid number of the oil. So this is a review, means that how we can do the purification practice or the reclamation process. There's 10 practice we can done. They have vacuum dilator, mechanical filter, contact process, by gravity, and so on. So in here, we are dealing with the contact process, means that we are doing a mechanical agitation to the transformer, with the oil, with the fuller earth. So the type of contamination that can be removed from this process is for the solid particles, the free water, soluble water, and volatile acids. Okay, so the related previous works that come from the reclamation process before, okay, we can see that from the first previous papers from Encho, they're using fuller earth by using a percolation by gravity or contact process, they call. So what happened to the oil samples, the methods that we have done by heating the oil and flow it through a cartridge contains fuller earth. Next, Wilhelm also do this by using fuller earth also, by using a contact process, by using a mixture of oil, and then Mr. Raymond also do this, but we are using another type of adsorbent. So in this project, the review, but we are trying to prove either it happen or not, it is can be done or not by using fuller earth. Means our mineral oil samples is get from in-service power transformer oil, which we get it from the MB distribution, and then we are using the UVVs as a method to know the dissolved decay products inside the oil. We're doing the total acid number, and then we do the breakdown voltage or the dielectric strength of the oil, do the reclamation process, and see what happens after next. So this is the transformer that we are used. We are taking the oil samples from this we got in-service power transformer. Then we do the contact process. Okay, means that we are doing the mechanical agitations by mixing the oil with the fuller earth. Next, we do the filtration process. Then, this is a method on how to measure. We are dealing with the UVVs. I'm using UVVs, and we comply the standards from ASTM 6802 to measure the dissolved decay products by using UVVs. And next, we are using total acid number. We are measuring the acidity of the oil by using comply the standard SMD 974. And next, we do the dielectric strength, they call as a alternating current breakdown voltage, by giving a high voltage in the oil, increase it, and see the level of the breakdown voltage occur by complying the STM D1816. So we can see that there's a physical changes. The in-service oil itself, it is in dark brown, means that the oil has been in service age, and then we do the reclamation process. If we turn to the light brown, means means that the fuller earth have shown what we call a good practice by using fuller earth, means that they have reclaimed or recycled the oil. But we need to extend this works, we need to do another cycle. Means that in this we are just applying only one cycle of reclamation process. If we do a lot of cycles, we can make the transformer oil become lighter, will become more bright. So by using the dissolved decay products from the UVBs, we can see that the dissolved decay products from first, okay, with the dark brown, it shows that it's a 500 absorbance unit. So it turns into around 360 something absorbance units, means that it has been changed in color. That's a physical change of the oil itself by using full earth. By using a total acid number, we measured it. Before this is a mineral oil sample. Before it's around 0.13 milligrams oil. So in total acid number is around 0.13. And after having the reclamation, it changed into 0.02. Means that the full earth have shown remarkable activity, means that they have reduced the acidity in the oil itself. Next, we focus on the breakdown voltage itself. So in the transformer, we need to focus on the breakdown voltage or the dielectric strength of the oil. So you can see that in the first, if the oil is in aged mineral oil, the breakdown voltage is around 8 kilovolt. But after having first cycle of reclamation process, we do increase into 50% of it into 12 kilovolt. To mention it before, to be used again, if we want to use again this oil in the transformer, we need to comply the standards of the transformer oil itself. In the transformer oil's specification, if we want to use the transformer oil, we need to have an acidity lower than 0.03. So in terms of acidity, it's shown that the oil has been reduced in terms of acidity. But in terms of breakdown voltage, according to the transformer oil specification, the breakdown voltage should be higher into 20 kilovolt. That the higher the voltage, the better it gets in the transformer. So to make it better, to recycle is better, I do have some some idea. If let's say we can improve more to increase the number of the number of reclamation cycles, because in here I'm just presenting only one cycle of reclamation. If we do numbers of reclamation and change the color itself, okay. For the first reclamation cycle, we do have it change into light brown, because if we do lots, maybe it change into the lighter one. It will come bright. So then it might increase the breakdown voltage, because the theory of the breakdown voltage itself, the higher the breakdown voltage means that the oil didn't have the conductive particles inside that, and also the reduce of the suspended particles inside, and also relative to the gassing tendency of the oil. So for the conclusion, I can say that but it is proof that by using reclamations, by using fuller earth, it is shown that there's a proof that shows that it is a reduce of acidity in the oil, and also an increase of the breakdown voltage or the dielectric strength of the transformer oil itself. Okay, so it proved that the fuller earth is also an effective adsorbent that mainly being used by other researchers. Thank you.
Thank you, Mr. Sharin bin Abdul Khalid.